Section 2.1 is linear equations and problem solving. So this might be some stuff that you've already seen before, but hopefully you can get a little refresher. So an equation is an x statement with two algebraic expressions are equal. When we solve the equation in x, we're finding all the values for x that make the equation true, therefore finding what we call the solution set. So there's three types of equations. The first is an identity, meaning every single number you plug in is going to make it work. Think of the same thing on both sides. So x plus 4 equals x plus 4. Any x value you plug in there is going to make it work. You see this example here where it's x over 3x squared. That can be reduced to 1 over 3x. These are in fact an identity as well. This equation, I'm sorry. A conditional, that's the one we see a lot. Certain values make the equation true. Probably 1, maybe 2, depending on what you're looking at. As we get up into cubics, quartics, we're going to be looking at 3 and 4 values that make the equation true, but it's a conditional. It works under certain conditions. And the last one is a contradiction, meaning no values make it true. What happens is in the end, you're left with two numbers, probably constants on either side, that are not equal to each other. So 4 is equal to -1 is not a true statement. No value will ever make that true. And what we're going to see next is solving fractional expressions. So before we solve fractional expressions, you need to find the LCD of the terms and then multiply. You have to get a common denominator. So basically, go-to way, if you're not sure, is just to multiply all the denominators together. There are ones that'll be smaller. That's your surefire absolute way. So here are the steps for when we're solving and there's a fractional denominator. I have x over 3 plus 3x over 4 is equal to 2. First thing I do is determine the LCD. So 3 times 4 is 12. That's how I come up with this number. I multiply each term by the LCD. Since I'm multiplying every single piece, I'm okay. I don't have to worry about sometimes when you get a common denominator, you multiply by 12 over 12 because it's really 1. Since I'm multiplying every single piece, I'm still keeping the equation equal. Once I do that, I'm going to simplify and solve for x. And I end up with x is equal to 24 over 13. And you can always go back and check your work. So once you have an answer, go ahead and plug it in. This one gets a little messy, but if you work it all through, you find out that, yes, 2 is equal to 2. Here I have another example. 1 over x plus 2 is equal to 1 over x minus 2 is equal to 3 over x plus 2 minus 6x over x squared minus 4. My LCD, I multiply them out. Keep in mind, foiling, right, works in this case because they're two binomials, but it won't always work. If you need to review multiplication, find the multiplying polynomials bulb on EduCanon. Find my LCD, things cancel out really nicely. I multiply each piece by x plus 2 over x minus 2. And what I notice is the denominator that it has in common cancels out. So here, these cancel. I'm just left with an x plus 2. Here, the x plus 2 cancels. I'm left with a 3, my original numerator, times an x minus 2. And on the end, the entire denominator cancels, and I'm left with minus 6x. Just a simple one-variable linear equation I can solve. However, my solution of -2 ends up needing to be checked, and what I come up with is it's rejected. I end up with, I plug in -2 and realize that I have 0 in the denominator, so my function is undefined. We looked at this. We looked at values you have to exclude from your domain, and in this case, I would have known right from the get-go I had to exclude 2 and -2 from my domain. Since -2 is an answer, it's my only solution here, I reject it. And what happens is this function doesn't have a solution. My solution is a null set. So I can either draw two brackets like this and leave them empty, or I can draw a 0 with a slash through it. Either one, this is an empty set and a null set. They mean the same thing. It means there's no solution. Notice that you have to check when we find one of our solutions makes an equation undefined. This is called an extraneous solution. So it is a solution, but it's an extra. It's not going to work. When we use algebra to solve a problem, we've seen all this before. It's based on verbal explanation. We call this mathematical modeling. We've all seen word problems. It says rectangular family room is twice as long as it is wide. The perimeter is 84 feet. What are the dimensions? Write yourself a let statement, right? If I let L equal the length, then 2W is equal to L. twice the length plus twice the width is equal to 84. I plug in, so it's one variable. I find that W is 14 and L is 28. We're going to save the height of the building example for in class and the inventory problem example for in class and jump to ready-made equations. Ready-made equations are called formulas. You've seen formulas before, you just didn't think of them as ready-made equations. But we can use them and either rearrange them to be set equal to another variable or just plug in and find a missing piece. So if we have a cylindrical can has a volume of 600 cubic centimeters and a radius of 4 centimeters, find the height of the can. I have a formula that relates the volume, the height, and the radius, and its volume is equal to pi times the radius squared times h. So I plug in the pieces that I know and solve for h, and I can find that the height of the can is 75 divided by 2 pi. This should definitely be a review. You're just plugging into an equation and solving for one variable. Same thing for number 7, you don't need to worry about that one. And we're going to do number 8 in class. Number 9 looks at averages, another word problem. A store generates Monday through Thursday sales of $150, $75, $125, and $180. What sales would be needed to generate on Friday? What sales would be needed to generate on Friday to have a weekday average of 150? An average, add them all up, divide by how many you have. I'm missing, this is Friday sales right here. I would write a let statement that says let x equal Friday sales. Combine like terms, solve for x, and I find that you'd have to sell $220 worth of material on Friday. 2.1 should definitely be a review. We're going to get into 2.2 next, which should also be a review. But if you need to brush up on multiplying polynomials, writing let statements, and writing linear equations from word problems, you need to jump back and look at Bulbs or Khan Academy videos that do so.